Welcome to this proposal presentation for a powered exoskeleton leg brace tailored for elderly users. This innovative design focuses on affordable, assistive technology that empowers mobility, independence, and rehabilitation, all while using simple, 3D printable components. As mobility declines with age, simple tasks like standing or walking can become significant challenges. This project proposes a powered leg exoskeleton that leverages 3D printing, a 12-volt actuator, and open-source electronics to support elderly individuals. The aim is to make assistive technology both accessible and effective, without the high costs associated with commercial systems. Our primary objectives are clear. First, to enhance mobility for elderly users. Second, to offer a cost-effective and 3D printable solution. Third, we prioritize safety, comfort, and simplicity in use. Finally, this design supports rapid prototyping for customization and iteration in research or home settings. The system is built from a set of modular and replaceable parts. The core is a 3D printed exoskeleton frame shaped to fit the human leg. It's powered by a 12V linear actuator, which is controlled by a microcontroller such as an Arduino or ESP32. A motor driver like the BTS7962 controls actuator motion. Power comes from a 12V lithium-ion battery. The setup can also include optional enhancements like pressure sensors, inertial measurement units, and safety switches. Here's how it works. When a user initiates a motion like standing up, a sensor detects the intent. This triggers the microcontroller to send a command to the motor driver. The driver activates the actuator, which extends or contracts to support the user's motion. This coordinated action eases the strain on joints and muscles, making mobility smoother and safer. The mechanical design is simple yet effective. The system includes a hip belt that supports the upper body of the exoskeleton. A linear actuator is positioned along the thigh to generate force. The knee joint uses a hinge or pivot to allow smooth bending. Braces at the thigh and shin hold the frame in place with adjustable straps, and the footplate distributes the load to ensure stability during standing and walking. This slide shows the electronics architecture. A 12V battery feeds power to both the motor driver and actuator. The microcontroller receives sensor input, like pressure or movement detection, and interprets the data. It then controls the motor driver to execute the needed action. This setup is energy efficient and can run for hours on a rechargeable battery pack. This diagram shows how the components are connected. On one side, the 12V battery powers the motor driver. The linear actuator connects to the output terminals. The microcontroller, shown at the bottom, is programmed to manage logic and control signals. A switch allows for manual control or emergency shutoff, ensuring user safety. One of the biggest advantages is that this entire structure is 3D printable. We recommend materials like PLA for prototyping or PETG and nylon for durability. The exoskeleton can be custom-fitted using body scans, making it highly personal and ergonomic. This approach dramatically cuts production costs and allows local or home-based manufacturing. The exoskeleton is more than just a device. It's a tool for independence. It can assist elderly individuals in sitting and standing without help. It supports walking by distributing load and stabilizing movement. It can be used in rehabilitation programs for stroke or injury recovery, and it provides daily assistance to those who struggle with leg weakness or fatigue. Exoskeleton design. 1. This showcases a labeled breakdown of the exoskeleton structure. Key components such as the actuator, braces, and straps are clearly visible. This illustration helps demonstrate the simplicity and functionality of the design. Strengths of the design. clear mechanical support. The electric linear actuator is placed at the thigh and oriented to assist knee extension, ideal for sit-to-stand transitions and walking. The knee joint mechanism is centrally aligned, allowing for natural flexion, extension with power assist, adjustable and secure fit. The multiple brace straps, hip, thigh, shin, ensure the exoskeleton is tightly secured to the user's leg, reducing wobble or misalignment. This is critical for elderly safety and comfort. Practical power placement. The actuator and mounting frame are positioned to avoid interfering with mobility while maintaining a center of gravity close to the body. 3D print friendly. The clean structural frame appears modular and printable with common materials like PLA, PETG, or nylon. Exoskeleton Design 2. This variant shows a different view of the exoskeleton when worn. It emphasizes how the components align with the human leg and highlights practical application scenarios, including assisted walking and rehabilitation support. In conclusion, this 3D printed powered leg brace presents a transformative opportunity in assistive technology. It's affordable, customizable, and scalable. Whether used at home, in therapy, or in a lab, it offers a clear path to better mobility and a better quality of life. Thank you for exploring this proposal.